Hey, my crazies, how are you? Today we're going to work on imaginary numbers. Where did this imaginary business come from?
Come with me, and you'll be in a world of pure imagination. Take a look, and you'll see into your imagination. We'll begin with a spin, traveling in the world of my creation. What we'll see will defy explanation.
If you looked at square root of 9, you would say, all right, that's 3. And the reason it's 3, is because 3 times 3 equals 9. So if you slip a negative in there, what do? You remember math rules, right? Math does rule. I mean, you remember your math rules, which say, two negatives, negative times a negative is a positive. A negative times a positive is a negative. So how are we going to get two numbers that are the same, because that's what you mean by squaring, to come out with a negative answer? It just doesn't work. But yet it does, right? This is where the imaginary number system comes into play. This is where it comes in. So what we agree now is this. When you have a negative radical, you quite simply just pop an I out and factor as you normally would. I'm sorry, simplify as you normally would. So watch. This guy here, let's go like that. I think you'll agree that that's legitimate, right? I'm factoring this 9 into negative 1 times positive 9. And what we do is we take this square root of negative 1, and that's what we call I. And now you have I radical 9. From there, you simplify the radical as you normally would. And whatever you get, and you don't get upset. And you attach the I to it. So what's this going to be? Very simply a 3. Well then, there's our I. So it's I times 3. But if you don't want to get kicked out of those math dinner parties that we're all going to,
They assumed he was one of them. Heir to a railroad fortune, perhaps. New money, obviously, but still a member of the club.
no one says I3 because that's obviously a sign that you don't know what you're talking about. You're going to say it very eloquently as 3I. It just rolls off the tongue nicer, doesn't it? So, for example, you don't say x3. When you're solving equations or factoring or whatever, you would say 3x. Same story here. So that's how you deal with i's. You see a negative radical, immediately just pop an I out and make it a positive. Then go about your business. 8i. It's that simple. Let's take a look at some practice. Okay, the first guy, negative 2 times the square root of negative 24. Okay, the first thing I'm going to do is pop that I out. Negative 2 times I times radical 24. Then I'm going to simplify this to be 4 and 6. Good house, bad house. Now I have negative 2I times 2 radical 6. What does that equal? Negative 4I radical 6. That's your answer. It's that easy. It's not bad, right? Okay, how about this guy? Okay, 4, take an I out, make it positive. Simplify as normal. 4I times 8, 32I. Now this is meant to trip you up. Whenever you see negatives attached to radicals, don't all of a sudden jump out and say, okay, I'm taking the I out. I know how to deal with this. Just be careful. This negative sign here is not under the radical. It's just saying simplify 72 and then multiply by negative 1. So if we do that, of course you remember to use your calculator for this, right? But if we do it by hand, I think we're looking at 36 and 2, which is 6 radical 2. And now we just attach the negative. And this guy here is going to be 3i radical 48. Radical 48 is 16 and 3. So to save time, I'm going to say that. So it's 12i radical 3. Pretty cool. So what have we learned? Negatives under the radicals, pop an I out. And yes, your I should have a little fancy hook at the bottom. It shouldn't look like this. You know, in math, when we use I's, we kind of have a little curly thing, sort of like pi, right? Pi kind of has little squigglies and curves all over the place. So does our I. Okay, so next step, you've got these pure imaginations, these pure I's, right? Like 5i. Well, now there's this new number system that we introduce. And the number system is called complex numbers. And it's very complex because it's comprised of a little bit of real and a little bit of imaginary, like all of us. Wouldn't you agree? So the format of it is very important, and that's what we want to learn on this slide. Again, it's all about the dinner parties. You want to know how to talk about this. You know, what is a complex number? It is an A and a BI. A is purely real, then BI is purely imaginary. Put those together and it's a new system of numbers called complex, and it's going to be so important to know this when we use the quadratic formula and when we have solutions to crazy polynomial equations. We have to know about these complex numbers. Okay, so let's dissect this. 2 plus 4i. What's the A? It's 2. What's the B? 4. Okay, those are my two real numbers. How about 5 minus 2i? What would you consider the A to be? 5, and the B, -2. Now this is awesome. How about 6? There's a really cool thing about math and numbers that any number can be really a complex number. So even this number 6, which just looks normal to me, I don't see anything imaginary about it, can actually be written as a complex number, and all numbers can. So here's my A. Just think about it. How would I get BI out of here? What would my value of B have to be so that it be gone? 0. Pretty cool. So the number 6, believe it or not, can be written as 6 plus 0i. If you want to write it like a complex number. But I mean, who does that, right? This is gone. Just wanted you to see. Now, something you might be thinking, this guy here, what's with the negative? You know, if this is such the proper way to say complex numbers and everyone's pinkies are out right now.
If you want to be fancy, hold your pinky up like this. The higher you hold it, the fancier you are.
How's that?
Higher.
Like that?
Now that's fancy. They should call you SpongeBob Fancy Pants.
Where did this guy sneak in, and doesn't that break the rule? If you're thinking that, I understand why. The deal is that the format is A plus BI, but if your B was a negative number, well then it would simply be A, minus BI. So don't think that complex numbers always have to have the plus in the middle. This really could probably just say A plus or minus BI, okay? So don't stress about that stuff. It's the A and the BI that are important. So now that you know there's this thing called complex numbers, let's add them. Let's subtract them. Let's multiply them. Let's do crazy things with them. And let's see how the calculator is going to help us out, which is really fantastic. But first, I want to do this one, and then I'll do this guy, okay? Then I'll show you the calculator. When you add complex numbers, don't be tricked. You see how there's parentheses here, right? I have so many students who say, oh my God, this is double distribution, this is FOIL, I'm going to do a box method. You get excited when you see the two sets of parentheses because your eye has been so trained to that all the way through middle school, Just notice that there is a plus sign here, so that doesn't mean multiply. It just says combine like terms. So when you add complex numbers, combine the A parts, 7 plus 2, and combine the BI's. So -4 minus 2 is -6. I. That's it. Nothing more to it. So what's the story with this? Okay, this is just a way to show you that i's are going to come out of here. Wouldn't you agree? An I is going to come out of there. So simplify this radical if you can. That's going to be a 6 plus, this will be 2 times 8i. See how we're getting ahead of ourselves now because we're so good at this? This will be 2 times 7 minus 5i. Cool, right? Okay, so what do we have? 2 plus 16i. That's our first guy. Plus 14 minus 5i. Okay, this is pretty much straightforward. You know, add the b's, we got 20. Add the i's. What are you thinking? 11? 16 minus 5? Yeah, 11. Pretty cool. Pretty cool. Pretty cool. All right, so this, my friends, is Zanfini and Murray's gift to you. This calculator is so amazing. You got to know the math behind it and the algebra, but look at how you can check your answers or at least avoid silly mistakes. Go to your mode on the calculator. Go down. Yours is probably going to be real. Right there. Yours is probably real. I want you to move over to BI, A plus BI, and hit enter. That will set your calculator to be able to deal with complex numbers, and it won't harm you when you're dealing with just reals. So you can always leave it in A plus BI mode. Let's go second mode to quit. And look what we can do. 2 minus 4. Now you might be asking, where's the I? Well, if you can remember that the I has a dot on it, that dot is like the decimal, right? That's where the I is hiding, right there. Second decimal. Boom. It even has the curly Q. It's beautiful. Okay, so what do we want to do with that guy? We want to take 7 minus 2i. Six minus 32i. Is that what I got? Oh, no, because I multiplied. You know what? I'm not even going to edit this video because this is what you're going to do when you multiply. Isn't that cool? We can multiply complex numbers and get that answer. All right, so sorry. I'll leave it in there because I think you're going to want to know that anyway. Can't believe I gave away all the secrets already. Darn it. Okay, so let me insert. Oh, 9 minus 6i. Very cool. So you can add them. And yes, spoiler alert, you can multiply them. So 9 minus 6i. There we go. Very cool. Okay. This one's on you. Do that on your own. You had some questions over here, right? In your notes? Okay. These are all on you. Finish those for homework. And I hope you have a great night. I hope you enjoyed this short video. And we will see you tomorrow.